In this video, we're going to look at what happens if the area that we're trying to find has multiple intersection points. All right, so let's say we're trying to find the area of this shaded region. If we look in any direction, it is never the entire shaded region, doesn't always have one color on the top and one color on the bottom. But what we could do is separate it into two different regions. So if we think about this left-hand region, green's always on the top, and the right-hand region, blue is always on the top. So basically we're just going to have to write this as multiple integrals instead of just one single one. And that's really the only thing we have to do extra in this video, is writing multiple integrals instead of one. All right, find the area of the region bounded by sine and cosine from 0 to pi over 2. All right, so this is going to look like this. Oops. All right, from 0 to pi over 2, sine goes up to 1, and cosine goes down to 0. Right, so we're looking at this kind of compound region. And where do they meet? So we know we start at 0, that's told to us. We end at pi over 2, but we need to figure out where they meet in the middle. When does sine of x equal cosine of x? And that's at the 45-degree angle, pi over 4. All right, so sine is equal to cosine at pi over 4. So now we're going to have two separate integrals. We're going to have one from 0 to pi over 4. I'm going to add the area from pi over 4 to pi over 2. All right, so we're just taking two different areas because there's two different values on top. In the first one, cosine is on top and sine's on bottom, so we have to do our integral that way. And in the second one, now sine is on top and cosine is on bottom. All right, then again, just to save time, make the computer do it. So from 0 to pi over 4, we're going to do cosine minus sine, and that gives us a number. And then we're going to do the same thing from pi over 4 to pi over 2, except for now sine of x minus cosine of x. And that gives us the same number. So both these are 0.414. We add those together to get 0.828. Right. These are values we could find the exact answer of. It ends up having a square root and stuff in it. All right, but just creating the integrals is what we're focusing on for the most part. All right, write the integral that would give the area bounded by y equals 2 cosine x and y equals 1. All right, so let's look at what this is going to look like. All right, 2 cosine x is going to just be cosine with bigger waves, and y equals 1 is going to be something like that. And if you were to graph it, -1 ends up being, negative pi over 2 is where this hits 0, and positive pi over 2 is this hits 0. So where's the area bounded by all that? We have this left-hand side, this middle part, and this right-hand side. So this one's actually going to give us 3 separate regions. For each individual region, we're going to have to create a different integral. We know the whole thing starts at negative pi over 2 and ends at pi over 2, but we need to figure out these other switch points. So that's when 2 cosine of x is equal to 1, which means cosine of x is going to be 1/2. And when is cosine 1/2? That is at pi over 3 on the unit circle, or going just backwards, that's also negative pi over 3. All right, so it's going to give us 3 different integrals. The first one starts at negative pi over 2, our full starting point, and goes to that first transition at negative pi over 3. We always take the top function minus the bottom function. So here the top function is the green function, and we subtract the bottom function. Then we're going to add to that from that switch point from negative pi over 3 to the next switch point, pi over 3. And in this one, the top function is 2 cosine of x, and the bottom function is 1. And our final one, from pi over 3 to the ending point at negative pi over 2. Now the top function is 1 again, and the bottom function is 2 cosine x again. Again, so we just want to write the integral. That's the integral that's going to be the solution to this area that we're trying to find. Here's one for you to try on your own. Again, just write the integral for the area bounded by this region. All right, the answer that you get looks something like what I have on the bottom. All right, so the picture is drawn to the left. All right, and we know we start at 0 and we end at 5. but there's a switch that happens in the middle. So the first thing I need to figure out is where does this switch happen? So this is when I set the two equations equal to each other, and I get to hit each other at 2 and 5. All right, so this ends up being 2, and actually 5 is that cutoff point right where we want to stop anyways. All right, so our first integral is going to be from 0 to 2, and the top function there is the red function, y equals 10, minus the bottom function there. Then we have to add our next area, which is going to end up being this. That goes from 2 to 5. Actually, I made a mistake. This should be a 2 instead of a 0. All right, 2 to 5. And we take the top function, which is now the blue function, 7x minus x squared, and subtract the top function, 10. So altogether, that's going to give me this area here from the first integral, and this area there from the second integral. All right, but again, main thing is being able to write the integrals yourself, and then just taking antiderivatives and plugging in values is just a lot of tedious work to do after that. So in class, we're going to practice finding areas between different types of curves. We can just do simple ones with just the x direction. We can have to change our mind and look at the y direction, or we could have switchovers where we have to change into multiple integrals.